Then I come to call up Sergio Calsamiglia, of Spain, who will give his talk. And please stick to the time schedule.
Okay, thank you, and thank you to everybody. Today I will present some of the recent data we have been developing in a commercial farm in Spain with the motivation of trying to find out, maybe in another revolution for the future, of the use of technology in trying to predict or help predict some diseases, in this case in the postpartum period. Now, I'm not going to go into how expensive is the postpartum diseases. I think it's sufficiently expensive. And there's a lot of wealth of data available, probably very highly variable depending on how you estimate this cost. But on the basis that this cost is sufficiently high, we'll probably have to think if we can do some preventive measurements measures that will help us to apply treatments in a rational way. Now, the problem is that when we have a lot of postpartum diseases, and as Seneca said, when you are in the middle of adversities, it's too late to be prudent. And therefore, the question or a motivation is, can we predict? Can we know which animals are at risk so we can do something on those specific animals? Now, we do know that we have ketosis treatments and hypocalcemia treatments that will be effective when you apply them to the potentially sick animal. The problem is that when we try to apply these as a preventive measurement, and we have, let's say, 200 cows, we're going to try to do this preventive treatment to all the cows when, in fact, only a small percentage of these animals will actually have a disease. So basically, that becomes an expensive approach because we are using 200 preventive measurements to reduce the incidence of a disease that is only going to affect a specific group of the animals. And that's not only an excess amount of treatment, but it's also expensive. And in this is basically the motivation that we would like to just treat these 40 animals and then not treat those that we think don't have a risk of getting that specific disease. Now, the problem is, how do we know? How do we know 2-3 weeks in advance that an animal is going to be sick? Now, the objective of that experiment was basically trying to see if the pedometers, as a way to control in an automatic way the behavior of the animal, is going to tell us whether an animal is prone to be sick, or even better, will tell us what type of disease is she more likely to get after calving or around calving time. So we actually went to a large dairy farm in Spain with about 1,200 cows that basically were having a bedded pack prepartum facilities. And in those animals, we actually use a system that it's a typical pedometer system in the animal. But the system also has an electric line connected to an activator, and then it makes a loop through the headlocks. And it creates a magnetic field in this area so that when the animal puts the feet in front of the feed bank, like 20 centimeters, means that probably she's with the head inside of the headlock, it will break that magnetic field, and that creates a signal saying this animal is in the feed bank. It doesn't say whether she is actually eating or not, but most likely she would be eating at this time. The system is relatively simple to install. It does require to do an installation in front of the feed bank, and then the animal, when it's in this position between this line and the headlock, breaks this magnetic field. So the experiment was basically, the rest is like any other pedometer system with a connection to a receiver and then to the computer. And the final thing is that this pedometer will measure actually what many of the pedometers today measure: standing time, laying time, the steps, but we'll also measure the swaps between standing and laying, and we'll also measure the time in the feed bank, and we'll also measure how many visits per day at the feed bank. So we have an idea of the behavior plus the behavior in front of the feed line. Now, basically, we were trying to see if the behavior will be reflected in more risk of retained placenta, hypocalcemia, dysplasia abomasum, ketosis, mastitis, or metritis. It's unfortunate that in this farm, for some specific reasons, the ketosis incidence was extremely low, so I will not talk about ketosis. They were actually had in place some preventive measurements for ketosis that were very effective, and therefore we cannot talk about ketosis. We did not have any case of ketosis. Basically, the design is taking account 21 days before calving, and we just put a pedometer and control this animal for the 21 days and take off the pedometer back to another cow in the prepartum period. Now, the reason we did that is we did not have enough money to have all cows with these type of pedometers. But it actually met the objective of our trial to try to see if the behavior in these 21 days was sufficient to identify sick animals or the specific disease. So the question, the hypothesis, statistical hypothesis is, can I identify a sick animal, an animal to be sick compared to an animal that will be healthy? Or even more interesting, could I actually say the specific disease? Could I say that an animal that behaves in a specific way will have a higher risk to have retained placenta or mastitis or maybe dysplasia abomasum? So I'll show you some slides on the general, I will show the data is very boring. So I'll show you some examples. This is just for a sick animal compared to a healthy animal. And this is the time accessed at the feed bank. And there's not much to say. You see the control animal that goes, stays in minutes, 200 minutes per day. Look at 20 days before calving, this cow is already behaving differently. I can tell you 2-3 weeks before that this cow is going to be sick. And it's pretty constant. It doesn't have much variation. It is a very well-established pattern. This animal is highly likely to be sick. And the difference is not minor. Is 36% less time in the feed bank, like when you're sick. Like when I have flu, the 3 days before, my behavior is different because I say, no, I'll go to work, I'll handle that. But my performance is not as good. Look, for example, what happens with the visits, number of visits at feed bank. You go from 9 to 8, 9.5 to 8. You decrease 15%. It's less clear, but it's relatively fairly consistent. So you use both criteria, maybe I can identify this sick animal. What about number of steps? It's also different. What about laying time? It stays, when you're sick, you're laying for a longer time. So actually, when you combine all these criteria, you can say, I have enough criteria to say that this animal is highly likely to be sick. So a sick animal will have less access to the feed bank, less visits to the feed bank, less swaps between standing and laying, less steps, and more laying time. Now, the next question is, can I predict a specific disease? I'll put just one slide for the metritis. 3 weeks in advance, the cow that in 3 weeks will have metritis has already a very distinct behavior in the feed access time. And if I do number of steps, it's a very clear difference, and it's for metritis. Now, the question is, can I separate metritis to other diseases? And I will now just go to summarize a whole set of graphs that basically will be in red lines saying that they're actually decreasing their activity, and then the green lines, they will be increasing that specific activity. And if you look across it, you will find out that no pattern actually is equal to the other one. So if you have an animal that has lower feed bank visits, could be any of these two diseases, but if in addition has higher laying time, it's dysplasia abomasum. And if you look carefully at the graph, each specific disease has a specific behavior pattern, which basically tell us that we might be able to predict what is the risk of an animal to have a specific disease in the time around calving. And I asked the farmer, if I tell you that a specific cow has a specific disease, would you react in a specific way? And they said in some disease I would, because you can have preventive measures, propylene glycol. You can try to do preventive antibiotic treatment at calving if you're going to have metritis, etc. So in conclusion, I think that we have, for hypocalcemia, to identify 21 days before calving. We have patterns that will identify metritis 21 days before calving, for mastitis, postpartum 10 days before calving, and for retained placenta 21 days before calving. I think this is exciting data that may provide us with a new tool to try to use in a more rational and profitable way our preventive measurements in the periparturient period. Thank you.
Thank you, Sergio. And thank you also for be sticking within the time. We have room for questions, so please raise your question in the static microphone in the alleys. May I raise one question in between? Have you pre-calculated your sample size needed to distinguish statistical differences?
We are, this data was prepared 3 months ago for the abstract submission. We right now have more data available. Okay. We're collecting data till the end of this year, hopefully having about 1,000 calvings altogether. We're calculating both the sample size required to be reliable as well as the error. How many, what is the reliability of the prediction? How many mistakes will you make as false positive or negatives? But that's ongoing.
Yes.
Hello, thank you for the very good presentation. Simon Dufault from University of Montreal. Right now you're using these change in behavior to predict future disease, but what are your thoughts about a possible causal effect? Do you think that something happened, they changed their behavior, and we're going to have disease later? Or is it their different behavior that are going to make them becoming more prone to disease later?
We have asked ourselves that question. I don't think that a cow 20 days before calving has already metritis. I think that it's the behavior, that it's actually the attitude of the animal that is going to cause a more incidence of metritis. However, in our research, our data collecting that we're doing now, we're looking at the pattern of the cows, of the same cow in the next dry period, see if that's a behavior that is repeated. And maybe some cows have a specific behavior. Let's say a shy cow will eat less and therefore will have more, let's say, ketosis. That will be an easy example to say. But we will collect data to see if a specific cow has a specific behavior that determines a specific diseases.
Then these could be things that we may be able to modulate with stocking density or other things like that.
Most likely.
Thank you very much.
Yes, please.
Rui Fortunato from Portugal. We already know that cows that don't eat get problems. It's a problem of interactions in the book. All the cows were put in the same day, 21 days before in the same group.
I mean, that was it's a commercial herd in a running way. You know, the dry period group had about 200 cows, and they were coming in and out all the time. They were all in the same group. So it was a large group of animals, and they were coming in and out as they were calving or getting dry.
The sick cows stay less time, and the cows that eat more stay more time. Do you know it?
No, there was no difference on like dry period length of all the cows sick compared to the other ones.
Fantastic presentation. Thank you.
Other questions? If not, thanks again, Sergio, for your presentation.